Alright, so here's your video for chapter 8.4, molecular shapes. Molecular shapes are referring to the shapes that the molecules take, and the molecules take certain shapes due to the VSEPR model. We use the VSEPR model to explain the shapes, and we're going to go over what is VSEPR, how do you use VSEPR to predict the shapes, and what hybridization is. So the VSEPR model is a valence shell electron pair repulsion model, and this is a model that will try to explain why molecules take certain shapes, and they do so to minimize repulsion between the shared and the unshared electrons from the central atom. So remember, everything just wants to be more stable. So to minimize the interaction, the shape will spread out anything that is attached to the central atom. So we can then divide the 360 degrees by the number of things attached, and then that'll give us the bond angle, and the bond angle is how the terminal and central atoms are attached. And remember that unshared pairs of electrons take up more space, just like siblings will take up more space in the car. Alright, so we have the basic shapes. We have linear, trigonal, planar, and tetrahedral. Now if you look at page 263 in your book, we can see a little bit better examples. So here we have BeCl2. So then Be is in the middle. We have the two chlorine atoms on the side. So this will make a linear model. If we look at beryllium in the periodic table, beryllium's right here, chlorine's right there. So beryllium. Alright, so then let's look at aluminum and chlorine. Aluminum and chlorine will make a triangle, and this triangle is on a single plane, so we call it trigonal planar because it's on a single plane. Even though it's a 3D model, they're all flat, and if you could lay down the AlCl3 on a flat surface, I suppose, if you were imagining it that way. So it's called trigonal planar when there's three things attached, Cl3, to a central atom with no lone pairs. Then we have CH4. We've seen CH4 before, methane. So we have carbon as a central atom, and then we have 1, 2, 3, 4 hydrogens attached, and that's 4 is tetra. So we have a tetrahedral because it's a 3D model. We have one going into the paper. These two are kind of popping out. Then we have not always 4 things attached per se, but sometimes we have ammonia. So we have NH3, so we have the nitrogen atom as the central atom with 1, 2, 3 hydrogens as terminal atoms, and then nitrogen, because it has 5 valence electrons, we have 1, 2, 3, and then 4, 5 for the unshared pairs. The unshared pairs are taking more space than they should, so unlike in the trigonal planar, we're going to have the terminal atoms being pushed down, so it forms a triangular pyramid. So we have a trigonal pyramidal. It makes a little pyramid if you see it. Then we have my favorite in the whole wide world, water. Talk about water all the time. We have the central atom of oxygen with 2 terminal atoms of hydrogen. Remember, hydrogen is always a terminal atom. Now this oxygen has 2 unshared pairs of electrons, so then these unshared pairs of electrons actually push down the molecule, and what should be a linear molecule is actually being bent by the lone pairs. Here we have trigonal bipyramidal, and actually we have, if you see here, we have 1, 2, 3 in the pyramid. We can do the same thing here. So we have, there we go. We actually have a second pyramid at the bottom. So we have triangles, and we have 2 of them, so it's trigonal bipyramidal for NBBR5, and then octahedral for SF6. So we have sulfur in the middle, and we have 1, 2, 3, 4, 5, 6 fluorine atoms. There are no unshared pairs, so we have the octahedral shape. Alright, and this is for your test tomorrow, and on Friday, and for your benchmark. So Not so hard, a line, a triangle, 4 things, 1, 2, 3, 4, tetrahedral, and 3 things attached, but it's being pushed down, so it makes it 3D shapes, so trigonal pyramidal. A linear that is being bent by lone pairs who are selfish and taking up more space than they should. Then we have trigonal bipyramidal, so we have 2 pyramids, and octahedral, we have 8 sides, because we have 6 things attached. Alright.